tree code that I found from PRC Web, Peter Cook here, and you can get to the original. I copied it into Tributary and adapted it a little bit to be able to tweak some of the parameters, namely the rotation of the branches, and animate it. And what I want to do is try to recreate the Oaklandish logo or something like it, decently close, using this code. And I figured, I just had the idea, not really sure exactly how I'm going to do it, but might as well record trying, right? Talk it out, see if we can't figure it out. So, alright, so the first thing in getting to know this code is to kind of look at the structure of a rectangle in the background. I believe that's just the background color. And then some initial values. Seed usually means like some variables to start with, and then these look like parameters to how to draw this stuff, right? So we can play with some of these. I bet this is like where the tree starts. So we can play with the x and the y. I'm not sure what a is. It's like some kind of rotation thing. Yeah. Let's see what L. Oh, a must be the angle probably. The length of each branch. It looks like. Oh, here it says too the depth. So we can do more or less. It's like. Maybe this is in decimals. No. Must be integers. Must be some offset. Alright, so then the change in angle between branches, the length of each branch, I suppose. Some sort of broccoli looking thing. And then the angle of rotation. And this is what I'm changing with the slider. I have this nice utility function that we can call tributary.anim, and it will go between the two values. I guess a little slower than so you can kind of play with that. I like that. This is just kind of how I normally explore stuff. Alright, and then you can change the color of the branches. Alright, cool. So then we have this branch function, which looks like it is recursive and because it calls itself, adds branches to an array. So we'll probably want to see what branches looks like. I'm not sure what regenerate is. Looks like it creates a branch of some sort. I guess you gotta calculate the endpoint eventually, the last branch. Next one, I'm not sure what this is. So this is highlighting the parents, so this must be the code that this does to highlight them. Alright, and here's the actual drawing. Looks like we're creating a line for each branch. So stroke width, basically based on the depth, I guess. And an update, which looks like you can click somewhere. I should be able to click somewhere. Let's just do S region. I guess it doesn't work. Yeah, so let's see what branches looks like. Console. I already typed it here. It's an array. Some elements of this array. See the angle, depth, the index, I guess, the length. Right, so it's all the data that describes this tree is in this object, right? So we have a list of them. And so here's creating a line for each one. We could do other things for each one. Let's just mess around and try some stuff. What I think I really want though is a path, right? Because I want these like smooth curves. You see on that? So we're gonna try. Let's first like play around with the line and do like a rectangle and then do a circle. You guys, right? You can just try some stuff out. So let's make this a rect. Rect. Let's do. Oh, I didn't. So I'm going to return d.l for the length. Alright. So now we have our rectangles, but they're not oriented in the proper way. And I think there was an angle associated with, like once the x and y, yeah, this does like some kind of math here. Endpoint. I wonder if, let's just try this. So we're going to transform. Oops. And the thing we want to eventually return is a string. And we're going to rotate things by something d.a. and turn it into degrees. That's not expected. Pretty cool, yeah. Let's see. I think I liked 0.5. Alright, well, this isn't really getting anywhere. I want to draw the path, so I'm just going to use x and y coordinates. So first I need a function here. I'm going to use d3 to speech that line, because then we can get some nice interpolation going for free, pretty much. This should be fine. And this should probably be d.x. This can be d.y. I guess we have one entry that has the start and end point. That's how I was drawing the line. Let's put these back. Delete these. Actually, let me save this. Because then the commit, just go back to the code if you are so inclined to mess with this for any reason. Yeah, that might be it. All this is I want to have just erase it. I'm gonna say points. So get points. Different branches. I think I gotta like not use some global variables a little bit because I want to draw multiple trees in the same code. So let's see. Points to be an array, and I'm just gonna go branches.for each branch. Points.push x one. So I'm gonna push a point for every branch, but also doesn't like this. See what things is wrong with this here. I'm not returning points. Let's go to console so it doesn't lag. Alright, so once we have our points, we do adder d. Nothing explicit about this. Style split. That's not a function. Let's see on that. I just gotta get declared at the top. Oh, we don't want it. There we go. So I was passing in the points array, but the path function takes in an array, so I need to just pass it in as one element here, so that d is the line. Although I'm not sure it is not a function. So make something else. Let's see, binary search time. Where's it called? Create. So somewhere in creates get points. Doesn't that stop? That's weird. Anyway, we got paths. Make the stroke width bigger. Alright. Looks like we don't want to actually get on every line somehow. Get rid of that. So I'm going to get rid of those endpoints somehow, but let's try line doing. That's weird. API. Let's find out the interpolations we can use. Basis. So, wow, that's kind of cool. What is the Alright, that's clearly not gonna look like it. Cardinal, some monotone. Let's try some of these. Let's go. Interesting. That's cool. I think what I really need to do though is get fewer branches, shorter depth. Let's turn this off real quick. Still nice and spell. Sometimes they have a left and a right, sometimes they don't. Do this. Ability. This is guaranteed for the first 2 levels. Now I just need to figure out what this extra crap is. Let's look at the branches one more time. So it should be What's next? In which case of this? Alright, let's try adding the lines again and see if we can see something different. X. Let's do it here. Run this up. That's interesting. Change the opacity. Yeah, I'm gonna do this. Seems the last one. Almost the last branch, right? So, now there's something I'm missing. Ah, the interpolation helps us see we're going like this. We're not going up each branch. So we're chasing the outline of this tree. So really what we need to do is go through and get each branch so we can draw the line. There's going to be a lot of lines. Basically, for all the endpoints, we need to go down their parents. Alright, so we can do this. Alright. So we kind of like get points, but instead of doing this, I'm going to say get hats, I suppose. And what we want is, let's see here, the depth of the greatest one. So all the ones with depth 4, which would be like the highest depth, I guess. Let's see here. Max depth is 4, so yeah. So we want to create a path for each of the leaf nodes, so the ones at the end, right? Let's see here. So if branch.depth is less than max depth, we're going to return. And then we're going to go, we need to like walk down its parents, so until there is no parent, right? So we need a recursive function. That's going to be like oops. Because now each of the branches that we have here is let's see, we're gonna have, so points, we're gonna have hats. We're gonna put points in this. We're just gonna get points out of. We're just gonna recursively push onto this array, so say x branch dot x y branch dot y. Then I'm gonna pass these along. Okay. We're going to use the parent index, if you recall. These all have a parent, which is the item before them in the array. So you can use that to look it up though. And then this is going to be So now we probably parent a couple times. Right, students. See this. Hey, there we go. So I'm missing the first root one, but let's we can fix that here. The very first thing should be the C. Oh, it's the very last thing that appears. Ah, right. Because we're starting at the end. There we go. There we go. Alright, let's close this real quick. Let's up the depth a little bit. That's more like this. Screenshot that. Let's get rid of these lines for a second. Would have been a good idea to keep them around in the beginning though. This is getting closer to what I was looking for. Now let's increase the depth. Actual material. Let's see. This time, like more like it. Now, I want to get rid of some of these branches. I should do it on it's is it even or odd? Just do this is ours. Is there still randomness here? This makes a very one-sided view. Does it do anything? Taking out branches. Alright. I feel like the split gets wider every time, so let's come closer. Just killing the coordinates here. Oops. Alright, well, I haven't had this long enough. I'm gonna save this, you know, stuck around this long. It's cool. probably revisit this again later. I got a couple other videos to make anyway, but I'll wait. You don't have to though. All right.
go. Put it on that beat, go.